This conference will now be recorded.
Let me start. Let me start my screen. Please let me know once you are able to see. Okay. So what is the difference between map, map partitions, map and map partitions? What is the difference between map and map partitions? Anyone? No difference?
Map is a function which takes an element as input and gives output as an element, whereas map partition will apply the function on whole partition at once.
Whole partition at once. Okay, good. Partition wise, the transformation will be applied. This is the most important interview question. People will ask what is the difference between the map and map partition. Okay, good. Okay, there is something called map partition with index. There is something called map partition with index. Let's do how we can apply that. So map partition, right? Yeah, this is a map partition. So let me show you a simple example for the map partition to map partition with index. That map partition with index is simply like based on the what I can say, like based on the index what you pass, so the transformation will be applied. So whatever the index we pass, it will apply based on that. Okay, let me show you an example. Let me show you an example. Partition with index. Okay, so what we can do. Okay, so let's take a simple data. So then we'll create an RTD. Let me do this way. Well, I think I already have a 1 to 30. I already have a number RTD. Okay, let me take a number RTD. Or is equal to number RTD dot map partitions with index. If you closely observe the map partition with index, it actually take the int, which is index and iterator. So we already know what is iterator. It is a operation based on the whole partition in the RDD, right? So the whole partition will be considered as a one collection, right? So that's the reason we are taking a iterator. So the first position is in index. Index means which partition. So as we know that the whole data has been divided into 8 partitions. Out of 8 partitions, which partition of the data you are looking for? Okay, let me do that. I'm looking for the second partition. Okay, so index, map partition with index. The first one is index. Let's say we'll call it as index. Okay, which actually takes its integer type, comma. Next one is iterator. I'll call it as a itr, which is iterator. So iterator of, I'll say int, because I'm going to deal with integers here. Now try to understand map partitions with index. Okay, so we're taking the two parameters. Just do one. Okay, two parameters. So I'm breaking it down. White type mismatch. Okay, let me complete the whole. The rocket. Okay, here what we need to do, based on the iteration, based on this index what we pass, I will try to do the uh, print the elements from that. Okay, that partition. Okay, that's the index. Uh, First I'll take this itr iterator dot, because I'm going to apply uh, for each. Try convert to list dot. I'll just do the map. I'll explain what I'm actually trying to do here. Okay, and this I need to print element, this element, if element is 2, sorry, not element, index is 2. If index is 2, because I'm trying to print the elements from the index 2. If index equal to 2, then we will actually print. Okay, got the elements dot iterator dot iterator res dot for each print partitions. Index, this index represent the what position we are interested. Actually here, this is the index we are comparing. Iterator actually help us to take the whole partition on this, because here I'm interested in the second position, second partition, and it will take all the elements of the second partition. Then I'm just printing those elements. To print them, I took the map transformation, because I need to extract the element by element. So here the element represent that. Here that element represent that. Uh, what I can say, like uh, the whole elements in the whole partition. So this element, the element, but what are the elements we are fetching from this iterator? If the index is 2, those elements only we are printing. Okay, let me execute this. We don't have this. HTML launch function. Yeah, because it is a map transformation only. Let me show you the console. Here you will be able to understand. Let's take the data on this. This is the data and this is the RDD we created. Okay, let me execute this map partition index. So here I have used if condition. So as we saw earlier also, in this if condition, what will happen? The map transform applies on the element by element for every element, right? So when it is applied on the every element, uh, what will happen here? When you are applying on every element, you checking here the condition. You are taking only the index two elements, so which is not index 2, which are not index 2, it means index 1, index 3, other stuff. What they will happen, they will not print anything, right? They will not return anything. So when you're not returning anything in the Scala, it will consider as a unit. If you're not returning anything in Scala, it's considered as a unit. So when you're returning unit, it will be curly braces. So let me execute this. Copy index 2 and index 2. I'm just taking that index 2. Then res dot collect. Happen, nothing is returned. Okay, index 0, 1, 2. It means 9, 10, 11, 12, 13 should be printed. Here it is printed, no? 9, 10, 11. It will take it later. Right. Let me divide the function. file numRTT dot map partitions with the in this I'm taking two elements, one is index integer, other one is iterator. Which is also integer type because our data is integer type. Okay, in this why it is not breaking. ITR iterated values dot to list. Why it is not taking? Index is there, iterator is there. ITR dot to list dot map and this element if IDX equal to or IND index equal to 2, index 2, then we'll just print dot iterator then dot collect. Why it's giving empty? It's not actually giving empty. If you guys look at here, 9, 10, 11, 12, 13. But why it is coming like this? Or some format or something is wrong here. So anyway, if you look at here, this is taking only the specific. I understand because I have given a print. Okay, instead of println. Yeah. So look at this 9, 10, 11, 12, 13. 9, 10, 11, 12, 13 is the second partition. This is the 0 partition, first partition, second partition. This is printed from second partition. Okay, so when you want to perform operation based on the specific partition, we will take index like this and we will perform it. Yeah, any questions so far? This is the partition wise. When you want to apply on the specific partition, we will do on the specific partition. Okay, so let's move on to the next transformation. um, okay, let me open this. Where is that? In the last session we did. How many of you downloaded that the document, which has all the partitions and all?
Ravi, why do we have a dot iterator after the function that we have written?
Which is this one, this one, because what are the
Yeah, yeah.
elements it is returning? It should be a collection of elements, right? So your
Mm-hmm.
second parameter is the list of iterator. Okay, you're taking that iterator
Mm-hmm.
and element by element you are applying the see. Okay, so I'll do one thing. Let me break and show you the things. Okay, val res1 equal to, if I tell here what you will get the list of when you convert to two list, you'll get all the elements, right? Okay, let me, how it will break. If I center, it will go with, okay. See, what is return type it is expecting? What is the return type it is expecting? Iterator. But
Yeah.
what you are actually returning? List. So
Mm-hmm.
after performing this operation, it should return iterator. So it is expecting the return type is iterator. That's the reason we have written iterator. Okay, clear, Rishabh?
Yeah, yeah.
Where is that? Where is that? We have opened that PDF, no? Mm, Databricks. Yeah, this one. Okay, let's see intersection union join part. But before that, let's go on. So this is what the narrow transformation which I have explained earlier. So each partition of parent RDD is used by or at most one partition of the child RDD. So parent RDD means this blue color, the child RDD means this orange color. The when you apply the transformation from one RDD to another RDD, the results will be transformed, right? So when you're transforming, the what is the meaning of this is the child RDD, it means partition to partition. If you look at this, if here one partition is there, the data in that partition will go to this partition. The data is not actually shuffled. But when you look at the Y transformation, it is something like a multiple child partitions may depend on a single parent RDD partition. It means the data is shuffled. If you look at this like this, Okay, so there are different type of operation like a map, flat map, filter, and all comes under the narrow, like by key operation, reduce by key, group by key, join by key, uh, sort by key. What are the key by operation you perform, it actually goes wider transformation. Okay, is this clear? Okay, let's move on to what is the lineage. The lineage, we are talking about the lineage graph and all of we talked about it, right? What is the lineage? This was the very early days of the Spark. This document has been prepared. So one of the challenges providing RDDs and abstraction is choosing a representation of them that can track lineage across the wide range of transformations. So when you apply the transformation, right, transformation 1, transformation 2, and so on, they will return you RDD1, RDD2, RDD3, right? So to track that flow, which is the logical representation of your DAG, the logical representation of your DAG, we will call lineage. The physical representation of the physical plan or physical plan representation of your DAG is called actually DAG, direct acyclic graph. Okay, so you can look at here. So anyway, you guys can look at the sample. Yeah, this is what group by key, reduce by key operations will comes under wide transformations. Okay. Okay, so map we have already discussed what it does. So let's if you assume this RDD has the three items in this, when you apply the map transformation, it will do the element by element operation. That's what the orange colors are creating, element by element. Okay, so we already discussed about it. I'm skipping them. Map, filter. Okay, filter also you can look at here. The same filter also element by element only. Okay, flat map also, but flat map will take one element but returns a trouble of elements. Look at here, it takes one element, it will break and returns a trouble of elements. It's also map, but after collecting all of them, it will apply the flatten. Look at this, first element iterable, second element iterable, third element iterable, but all of them it been flattened. Okay, like this, all will be flattened, single element will come. Okay, you can sorry yes. So return a new RDD by first applying a function of all elements of this RDD and then flattening. Okay, group by. Yeah, let's do an example for the group by. Um, okay, so to do this group by, let's take. If you look at here, then there are some names. Okay, James, Anna, Fred, John. Right. I want to group by the first character. So we have to extract the first character. Can anyone tell me how we can extract the first character? Uh, first character in a string.
Caret function.
Yes, we have to use the char at function. We have to use char at function. So character of 0 will actually returns you the specific character. Okay, let's look at the simple example here. So you have a names like this. So every name will consider as one element, and here what we are doing, we're extracting the key and we're returning it. We're extracting the key first key and we're returning it. Okay, after that we're grouping them. This is one group. They start with the J, it's one group. You start with F, it's one group. You start with A, it's one group. Like that, we have what I can say, segregated. It's very simple to do it. You have a collection. You have a collection like this, and but when you're applying the group by, it is not group by key. It's a group by. And what you are actually doing here, you are taking a key. You are taking a key and key comma element, key comma your element. Okay, any doubt here? Any doubt here? Similarly, you have a group by key also. I'll show you an example for the group by key as well. Here you are grouping by a specific character. You're grouping by a specific character, or you can also group, you can also take some number of elements and you can group by like odd numbers and even numbers like that. Okay, let me show an example of this first. Okay, then we'll see the group by key. Okay, so I'll just copy paste from this. Okay. I'll take this also, numbers also I'll take. Okay, I'm taking list, parallel animals, these things I'll just remove them. I have all are different characters, right? Let's take same names with the same character. Hmm, cup. Okay, these are my animals. So now let's do animals will be grouped by it. Okay, let's take this example and name it as animal RTT. Animal RTT. Okay, so we need to group by this specific character, right? So if you look at this here, where is the document? Yeah, if you look at this is the array which we have created X. In this we are grouping, but we are just extracting the first character. If you look at this, we're just extracting the first character, nothing else. Okay, that first character, whatever we are extracting, right? Internally, what it does, it take that character, it takes that character, and whatever the character is emitted with this character, is there any other elements? Okay, let me show you here. The reason to bring here is to show that animal rdd dot gloom dot collect. If you see this, first array is dog, second array cat, third array is this one, fourth array. What I do, I'll not create these many things. I'll go with three I'll go with 3 partitions. Okay, then let's see. This is first partition, second partition, third partition. Okay, so now I got the group of elements. So let me go ahead and apply equal to animal rdd dot group by what we're trying to do here, we're going to take the first element. We're going to take the first element. Look at here. Sorry, first element, character of 0 in this RDD. Okay, so let's take, we'll go with the element. Okay, so element dot char at 0. 0 means first character. Okay, return. If you look at here, the return RDD type. This is RDD character uniterable. Character uniterable of string. Character and iterable of string. So if I do group by, 1 second, come, mummy under the oh group meme by this collect. If you look at this, look at here, for F, whatever the words are start, whatever the elements start with the F, they have come, and whatever the elements start with the R. So compact buffer is nothing but a group of elements. It's also one type of buffer. We'll talk in detail about this compact buffer. It's nothing like an array or nothing like an array buffer, similar kind of thing. Okay, so don't get confused with what it is. So you have a R, with the R is only one element, with L we have only one element, with the C we have a cat come cub, we have a D with two elements, with so like this it has been grouped, right? Similarly, take the numbers as well. Number RTD also, it's a group, it's a grouping, like how we did a group by operation in SQL. Similar operation here, group by. Okay, suppose if I'm grouping by order ID, so whatever the elements comes under that order ID, so all the elements will come, right? So it will be grouped as a single entity, right? Similarly here also. Okay, so let me show you this number. Let's say I'll also, this one also I'll group by 3 partitions. Three partitions. Okay, now here I want to segregate two groups. One group is even numbers, one group is odd numbers. Can anyone help me how I can do this? Can anyone tell me how can I do that?
Yeah,
No.
we need to write val group R by RDD, then equal to num RDD
Even odd RDD
equal to
odd RDD integrated equal to num RDD dot, which
num
operation I
group
need to
by
apply? Group by
ELE
group
bracket ELE
will take element
lambda. Yeah, if ELE modulo 2 equal to 0, then ELE else then again yearly. So it will divide into two parts.
But where you are specifying it's even and odd. So I understand what I'm trying to say. If you are saying yearly is modulo by 2, it's 0, then you're elementing yearly. But if this is not the one, right? Here, I'll tell you, here you just specify element even. It's an even number. Okay. Else,
Mm-hmm.
you'll specify odd. Then specify odd. Okay. You got the RDD. So now even odd RDD dot collect. Dot collect. If you look at here, even odd. Go. Mummy go. Mummy at the door depot. Mummy door depot. Okay. Got it, Rishabh? Because we anyway that is what we need to
Yeah, yeah.
understand. So here, okay, I didn't write both of them here. Let me copy paste it. One second. Okay. The other one is okay. Do you understand this? So here what we are actually trying to do, we are taking the element, we are extracting the first character. So rest all is taken care by your group by operation, right? So you are specifying what is your grouping key, that nothing else. You are specifying what is your grouping key. Here also same. This is my grouping key. If it is divisible by 2 and even this is my grouping key. Understand, Rishabh? So if you do that, if you extract the grouping key internally, it actually what it does, it takes whichever is match, whichever the elements match with that key, it will be grouped,
Yeah, Ravi.
right? Okay. Any questions? So don't get confused with this compact buffer. Compact buffer is nothing but like your array buffer. You guys, we saw array buffer, list buffer in Scala, right? The same.
Here, one question I have.
Sorry, ma.
One question I have.
Okay, go ahead.
Just a little bit confused where if we are defining the comma
Yeah.
3, so that particular 3 is dividing into 3 multiple partitions. So suppose tomorrow if the data size is getting huge, like probably 1 GB or more than that, then in that, how we can define the number of partitions?
Okay, your question is that, let me reframe what you have what you're asking. So if I'm specifying my number of partitions are 3, tomorrow if I get the more number of huge amount of the data, how we can redefine the number of partitions? Is that the question?
Yes, yes.
Okay, there are two functions available, two transformations I can say, which is something called repartition and coalesce. The repartition and coalesce, which we'll see in the coming sessions. With the help of the repartition, we can increase the number of partitions or we can decrease the number of partitions. Similarly, we have something called coalesce. By using the coalesce, we can reduce the number of partitions only. We cannot increase the number of partitions. Let's take an example of this. Let me take this opportunity to explain this. So if you see num_rdd, how many partitions are there in num_rdd? I have 3 partitions. So I want to reduce to 2 partitions. Look at here, there are 2 ways, but I'm using the first way. Repartition. I'm reducing to 2, from 3 to 2. Now we can check how many partitions are there in this. Can anyone tell me why this is? Can anyone tell me why it is not applied? Because
You
it is
need to
not changed.
assign.
We have 2 partitions. Okay. So let me print that dot room dot collect. Okay, only 2 partitions have been created. If you see rep dot todebugstring. What is a todebugstring? Okay, look at here.
It will provide the graph.
First we have does the parallelize method, then some map transformations are there. Then when this is actually you are doing a repartition. Okay, the repartition actually returns you map partitions. Parallelize, repartition. When you do the repartition, internally the data will be shuffled. After shuffling the data, it will again partition. First it shuffles the data, then it partitions the data. Okay, then the final data is shown here. Okay, similarly, I want to increase the number of partitions. Let's say I'm saying 4. Let's say 6. I'm going to increase. Actually, it has the 3. num_rdd has 3. Now I'm from 3 to I'm increasing 6. Okay. Now I have increased the number of partitions. How many partitions are there? 6 partitions are there. What does it mean? With the help of the repartition, I can increase the number of partitions or I can decrease the number of partitions. Is this clear?
Yeah.
I can increase the
So,
number of partitions.
is there any
Go ahead, Ma.
calculation like for this particular
Sorry,
data?
your voice is not clear.
Now,
Sorry. Yeah.
so my question was like, how we can decide based on the data
Sorry, Ma,
whether
it's not clear. Guys, is that a problem with me or is everyone is facing the same?
I'm not able
Anyone?
to hear her properly.
Okay.
okay, I think the problem is from my end.
Could you see? There is echo is coming, ma. There is echo is coming. Have you connected
Okay, sir.
two devices or single device?
No,
Single
no,
device.
single device. Yes.
Okay. Can you close to the mic and ask?
And no
No, ma.
problem, sir. Continue. Continue. I ask in the group itself because I'm not able to.
This question, I'm able to hear that part, but I'm not able to hear other part. I don't. Okay, fine. So this is the repartition. So with the repartition, we can increase the number of partitions and we can decrease the number of partitions. So what we have understand, when you do the repartition, it will happen the shuffling. Not only when you reduce, when you increase also, the shuffle will happen. Let me show you that.
Ravi, can we view this 2 debug string graphically, or else we can view it only in Spark Shell?
Graphically means I didn't get you.
I mean in browser like that. How exactly the transformations and the partitions are happening, the flow.
Those are you are already seeing in your Spark UI, right? Spark UI, you have a DAG, right? ep6 dot 6 dot 2 debug string. So whether irrespective of increase or decrease, there will be shuffling. Shuffling will happen. Data shuffle will happen. Then partition will happen. Okay. Let me show you the coalesce. Okay. There is another thing called coalesce. Well, first I'll show you the reducing. I'll reduce to 2 numRTD dot numRTD by default is a 3. Okay. Coalesce. I have reduced to 2 dot bloom dot. You have 2 partitions. Okay. If you observe closely, let me numRTD dot gloom dot collect. Can anyone tell me what is your observation here? Above coalesce dot gloom dot collect, numRTD dot gloom dot collect. What is your observation?
In college, partitions got reduced. In repartition, partitions are increasing.
No. I'm talking about only coalesce and numRTD. Look at the output, gloom output, gloom dot collect output. Okay, let me explain. When you do the coalesce, okay, this is the first RTD. Okay, on top of this we did the coalesce. If you see the first RTD, that's called num RTD's partitions. Partition 1 has 1 to 11. Partition 1 has 1 to 11. Partition 2 has 12 to 23. Partition 3 has 24 to 35. Okay, after doing a coalesce, reducing to 2, is the first partition changed? Is the first partition changed? The second partition, you see what happened? Second and third partition in NumRTD has been clubbed and set as a single partition. It means your coalesce will not shuffle the data. Let me show that. Do you see shuffling here? See the see the graph for the coalesce and see the graph for the repartition. Both are in the same screen. Try to observe closely. Shuffling is there? There is no shuffling. Yes or no? Let me show you increasing the number of partitions. I'm increasing to 6. Try to remember. I'm increasing to 6. Look at here. Okay. I'm trying to do the gloom dot this. Okay. And I'm trying to, yeah, to debug I can show you, but nothing. Does it increase the number of partitions? Does it increase the number of partitions when I do the coalesce of 6 on numRDD? On numRDD, I try to increase 6. Does it increase the number of partitions? Yes, no. Yes, no.
No.
It
Yes,
is not
but only
increased. It is not increased. Why yes? Who is saying yes? Where it is increased, ma? It is not increased, right? How many partitions are there in the numRDD? 3 partitions only, right? In numRDD we have 3 partitions only, right? When you try to increase to 6, don't get confused. Above 1 is 2. That is done. That is we did on the numRDD. We stored into coalesce of 2. Now we are trying to increase the number of partitions on the numRDD. Is this clear? Yes, no.
Yeah, Ravi.
Okay. So it means when you want to increase or decrease the partitions, we will go with the repartition. But the repartition has shuffling operation inbuilt. What it does, the meaning of this is, okay, shuffling means, suppose by default I have 3 partitions. Okay, I want to increase the number of partitions to 6. What it does, it will group all the 3 partitions. It means it will collect all 3 partitions data. It will shuffle again repartition. Again it creates the partition. Okay, but when it comes to the coalesce, we cannot increase the number of partitions with the help of the coalesce. We can only decrease. So while decreasing with the coalesce, what it does, whatever the extra partitions are there, let's say I have a 3 partitions. In this case I'm reducing to 2. One partition is extra. That one partition, it merge with an existing partition. It will not it will not collect all the data. Repartition, I mean shuffling and repartition doesn't happen. It will coalesce. It will just take the extra partition and merge with existing partition. It will take the extra partition and merge with extra existing partition. So what happens here, it avoids shuffling part. Clear? Varsha, is this clear, ma?
Yes, Ravi.
Okay, so this is about repartition and coalesce. Let's talk about the reduce by group by key. Group by key operation, I think we can talk tomorrow. We'll see tomorrow. Let me, I think this one, this I will put into console. Any questions, please ask me.
Ravi, can you show this in Spark UI?
Which one, ma?
I mean, we are doing like you did, right? To debug string. It is showing flow like from map partitions, shuffling, then repartition.
Okay. Okay. You see the DAG?
Yeah.
Clear? This one only, right? You are asking.
Yes, Ravi.
Parallel, then coalesce, then gloom, then collect. The bottom is the collect one. I mean, if the collect is the action, then only it will get processed, right? Okay. Any other questions? Okay. So that's it for today. So let's connect in the next session. So we'll see in detail. This is also most important interview question, guys. So what is the difference between the repartition and coalesce? People ask. They may ask directly, or they may ask like, I want to reduce the number of partitions or increase the number of partitions. How will you do? So they may ask that way. Okay. So since we are talking about the partitions, okay. So I want to discuss about the creating our own partition. By default, there are two partitions. One is the hash partition. Other one is the range partition. Try to keep it. I mean, make a note of it. One is the hash partition, other one is the range partition. Apart from that, we can create our own partition. This is all custom partition. So we will discuss tomorrow about a custom partition. So the partition algorithm actually decides uh, how to divide your data when a shuffling is happening. How to divide the data? Which partition? Which key has to go to which partition? Let's say I have three partitions, and one key is there. Whether the key has to go to the first partition, second partition, or third partition, how it will be decided? That is based on the partitioner algorithm. There is something called partitioner algorithm, so that we will see in the next session. So you guys are very well aware what is a how the partition happen from the hive, right? The hash partition, how the hash partition happens? It will take the key, does the hash code, it will find the hash code and modulo by the number of partitions. Same functionality here also with respect to hash partition. If you don't want to go with a hash partition, you can go with the range partition. The range, like a 0 to 100, one range, 101 to 200 is another range, like that. And third one is you can write your own custom partition, so that we will see in the next session. Okay. Any questions?
Ravi, in Hive, what is the maximum number of partitions we can give? Is there any threshold?
Yes, we do have a threshold, right? Per node it's 1,000 by default.
Okay.
If you open the document and see that, you will find that not the document, what are the nodes I have shared, the hive nodes. If you look into the hive nodes, you have that search for the partition, so it will show that how many partitions per node it can create. Okay. Any other questions? If no questions, we can leave for the day. It's already 9:10. Thank you guys. Thanks for your time. Have a wonderful day.
Thanks, Ravi.